in the 4th week of the first quarter, and I am Ma'am Fabrero. I will be discussing the topics for this week. First off, the objectives. First, illustrate a geometric sequence. Second, differentiate a geometric sequence from an arithmetic sequence. So basically, you will know the difference between a geometric and arithmetic sequence. Third, find the next few terms of a geometric sequence, missing term, common ratio, and number of terms in a geometric sequence. First, find the given number of geometric means between any two terms. And lastly, find the general term or end term of a geometric sequence. So before we start, if you have any questions after the discussion, feel free to ask questions from your respective subject teachers. Let's start with a review. Arithmetic sequence. What comes first into your mind if you are being asked of an arithmetic sequence? Okay, common difference. Because in arithmetic sequence, there should be a common difference. What do we mean by common difference? It means that all the differences that you will get should be the same. So that's why it is called common. Now, in this word, common difference, what operation will we use in finding the common difference? Okay, yes, it's obviously subtraction from the word difference. Now, from last week, it is denoted that we represent common difference as small letter d. And we have here d equals a sub 2 minus a sub 1, which means that the second term subtracted by the first term. So it does not mean that you will only do it once, just for the second term in the first term. So for example, there are 5 terms in a given arithmetic sequence. To find a common difference, you need to solve for all the differences using all the given terms. So you subtract a term from its previous term. And then it can also go on like a sub 3 subtracted by its previous term, which is a sub 2. We also have a sub 4 subtracted by a sub 3. And then a sub 5 subtracted by a sub 4. Formula should be all the same because we are talking about common difference, which is the key word for an arithmetic sequence for us to identify if it is an arithmetic sequence. Let's have an example. Identify the following if it is an arithmetic sequence or not. So we have negative 1, 2, 5, 8, 11. So how many terms do we have here? 1, 2, 3, 4, 5. So there are 5 terms. So we call a sub 1 negative 1 our first term, a sub 2 our 2 the second term, 5 as the third term, 8 as the fourth term, and 11 as the fifth term. So again, the question is, identify if the sequence is an arithmetic sequence or not. So again, how do we identify it? Of course, using the formula d equals a sub 2 for any term subtracted by its previous term. Okay, so let's do that. Let us find the common difference for the sequence negative 1, 2, 5, 8, and 11. So we start with the second term, a sub 2 subtracted by a sub 1. And in this one, this is our a sub 1, our a sub 2, a sub 3, a sub 4, and a sub 5. So we start with a sub 2 subtracted by a sub 1, 2 minus negative 1. So d equals 2 minus negative 1. And you see, we have two same signs. So if they are positioned like this, we multiply them. And a negative multiplied by a negative becomes positive. Yes. So we have 2. Since negative and a negative is a positive, 1. So 2 plus 1 equals 3. That is for a sub 2 minus a sub 1. Let's proceed to a sub 3 minus a sub 2. So we have d equals a sub 3, which is 5, minus a sub 2, which is 2. 5 minus 2 is equal to 3. Next, a sub 4 subtracted by a sub 3. So d equals 8 minus 5. 8 minus 5 is equal to 3. Lastly, 11 minus 8, our a sub 5 and our a sub 4. So, d equals 11 minus 8, which is also positive 3. So you see, observe, we have 3, another 3, 3, and 3. So all the differences that we got are all 3. Okay, is this an arithmetic sequence or not? Yes, it is, because the common difference that we got is 3. All the differences that we got from the previous solutions were all 3. Therefore, we can call this an arithmetic sequence. Okay, so before we start, I want you to bear this in your mind before we start our lesson for the week, our actual lesson, the geometric sequence. The only way to learn mathematics is to do mathematics. That's from Paul Halmos. So, if you will not do it, you will not learn it. So, practice. Practice, practice. What is a geometric sequence? From mathematical definition, it is a set of terms with common ratio. Let's analyze what is a common ratio is. A common ratio is the ratio of a term from the previous term. But then again, what is a ratio? Ratio is the quotient of two mathematical expressions. So for us to really understand what is a common ratio, let us put this into one definition. So we can define common ratio as the quotient of a term from its previous term. So quotient, term from its previous term, meaning, what do you mean by quotient? We divide a term from its previous term. So in this one, let's use the following sequence. Let us use this as an example. 3, 6, 12, 24, and so on. And so 3 is our first term, denoted as a sub 1. 6 is our second term. 12 is the third term. 24 is the fourth term. Now, find the common ratio in this given geometric sequence. So from the previous definition, common ratio says that it is the quotient of a term from its previous term. Okay, so we can denote common ratio as small letter r equals a sub 2 divided by a sub 1. Okay, question. Why didn't we use 3 first, or the a sub 1? Why can't we divide it, let's say a sub 1 divided by something? Yes, we cannot start with the first term because it does not have a previous term. So you cannot divide 3 by something because there is none. So therefore, we will start with our second term, which is denoted as a sub 2. So what is the previous term of 6, which is our a sub 2? It's 3. So that's why we can divide it by r equals 6 divided by 3. A sub 2 divided by a sub 1, which is equal to 2. Next, just like in arithmetic sequence, we need to find all the ratios of each term divided by its previous term. So until 24, we should solve for the common ratio until 24. Okay, let's proceed to the third term. So we have 12 as our third term. What is the previous term of 12? Okay, the previous term of 12 is 6. So we will divide 12 by 6, which is also 2. Next, last term, we have 24. What is the previous term of 24? Yes, that's 12. So 24 divided by 12 is also 2. So notice that we have 2, 2, and 2. All the ratios that we got are all the same. Therefore, we can say that this sequence breaks sequence because, again, the common ratio are all the same. That's why it's common. Let us identify the difference between an arithmetic sequence from a geometric sequence. So we all know in arithmetic sequence, we have what we call the common difference. While in geometric sequence, we have common ratio. In a common difference, as the word difference suggests, we use subtraction. So if we denote common difference as small letter d, we subtract a term, let's say a sub 2, to its previous term, a sub 1. Now, if we're going to compare it to geometric sequence, we have the common ratio, which suggests, again, ratio means getting the quotient of two terms. So, if D suggests or denoted the common difference, R, small letter r, denotes common ratio. So, if we have, let's say we use the second term and the first term. So a sub 2, since this is common ratio, we divide a sub 2 by a sub 1. That is one obvious difference from arithmetic and geometric sequence.